I'm going to dive right into the questions that we have queued up here. And the first one here is that there is an awful lot of talk about born in the cloud applications, and this seems to perhaps be in the opposite direction. This is taking applications that are not necessarily born in the cloud and putting them on the cloud. Does having applications be cloud native or born in the cloud versus Datometry's approach, does it make a big difference? Does it matter?
Yeah, so there are a couple of elements to it, and that is building new applications, building them in the cloud using cloud native implements, Cloud Foundry, for example, or other frameworks, etc., is obviously the way to go forward. But what do you tell an enterprise customer who has probably tens, if not hundreds of millions of dollars of application logic right now that they need to move to the cloud? And so we're actually, if you will, we're separating the problem of developing new applications versus moving. And a lot of people kind of initially are a little hesitant about this, as you can imagine, because it's really a paradigm that didn't exist in the past. It was really, well, you either stay in your data center or you move, and then you need to make a significant investment here to rewrite and recompile and reconfigure and all that. What we allow people to do is kind of really view these as two separate problems. Move your applications the way it is, move your enterprise to the cloud, be able to tap into these cloud-native databases, get the benefit, get all the goodness that comes from that, and then on your own time, decide when and how you want to rewrite or develop new stuff. Because at the end of the day, nobody has the money or the time to go back and, if you will, fix existing, running, and perfectly fine applications just because they move to the cloud. That way, we allow enterprises to really focus on the going forward and focusing their energy and their innovation really on building new applications and having at the same time the benefit of just bringing all of their existing stuff along.
Okay, I have another question here. You mentioned that you are not doing any heavy processing in the translation tier. How is it that you handle functions that are present in the original database but are missing in the new database? For example, that need emulating in the new environment?
Yeah, that's a very advanced subject. I'm glad you bring this up. So naturally, what we do is replace both syntax as well as clauses with what are equivalent implements on the new database. But very much so, there are a couple of things that cannot be expressed. And functions is a great example. So, for example, if you look at stored procedures, some of the new cloud databases do not have or do not have yet support for these. And so in that case, we actually do something fairly sophisticated. We unroll functions, so to speak, in the mid-tier, because a function at the end of the day is a stack of individual statements with a couple of local variables with kind of state to that. But they are usually transactional, and they're executed kind of by executing individual statements. And that is something that we pioneered very successfully just a quarter ago, where we actually unroll these functions and execute them for you. And that makes a couple of systems that do not have stored procedures suddenly appear as if they had stored procedures.
Okay. Another question that we have here is if a customer were to move to a cloud database, does Datometry have best practice regarding Cloud DR?
So on that front, so far we've actually gotten a lot of mileage out of the DR implementations that public clouds already offer for stateless servers in general, or also for database servers. And in all of the scenarios that we've worked so far, that has been a surprisingly effective and to-the-point solution. So the good thing here is, so to speak, that all the best practices that you've already been looking at on your journey to the cloud, how to use load balancers, how to use VIPs, how to use all of the other kind of auto-scaling groups, etc., all of this immediately applies to Datometry, and that makes the implementation and the deployment just kind of a very simple thing out of the box.
Another question, one that I actually rather like as a question here. How long do you typically execute the testing phase in order to capture all of the SQL that's being used by an application? And what about the timing? Do you test this over the course of the year and for example, make sure that you find all the yearly functions that might be at year end or quarter end or so on and so forth?
Yeah, this is a very good one. So let's briefly take a look at how we would execute a POC typically. And that is, we ask a prospect to give us their query log or take our product and run their query log on, let's say, their existing data warehouse through HyperQ. And we run our product in a special mode called Query Intelligence. And that allows you to run all of your queries simulating the execution. There's no other database system in the picture here, but just taking that workload and simulating it, and HyperQ does the whole analysis, does the whole optimization, etc., and gives you at the end of the day, and this is literally typically a day worth of work, gives you a scorecard that says, hey, these are all the things that we found in your workload. This is all the stuff that you should be aware of, and these are the things that we could translate. We even detect, for example, rogue queries that we find in every log where these are queries that have either syntax errors or referencing tables that don't exist, etc. And so we give you a full breakdown of what's going on in your box today. And that allows people kind of to immediately get a visibility into their workloads that they wouldn't get anywhere else today. You can't, from any database today, to the best of my knowledge, get that information, get kind of the breakdown of what are the features you're using, how often do you use it, the whole usage statistics. And that is usually the first step in an engagement where we tell you, okay, this is all the stuff that we found in your system, and we're confident that this will run on the other system. That's stage one, or phase one of the POC. And then the second phase is really around, well, let's just run that stuff. Let's stand up that cloud database, load some data in there, and run these queries. And when you look back about a decade ago, or a little longer than this, and I've been in this, obviously in this space much longer than that, it was really about millisecond parity when people wanted to move from one system to another. But in the cloud, this has fundamentally changed. Because, for example, if you have one query that just doesn't perform so well on that new system, you're in the cloud and you just crank up, let's say, resources, you scale, you take advantage of the elasticity. And that actually is one of the fundamental principles that we exploit, where it's no longer about speeds and feeds down to milliseconds on a specific hardware footprint, but is really about getting the value from the cloud and having that elasticity. And that has completely changed people's perception about these things. But naturally, HyperQ lets you, at basically no cost, so to speak, test drive your query workload on a completely different database. And so you get a lot of the insights as to how does this new database that you're looking to go to, how does that perform, how does it scale, etc.
Okay, I have a number of questions here about bringing the data back from the cloud, and these come in a couple of different examples, but generally revolve around if you are doing something like a DR over to the cloud, or you are temporarily attempting to burst to the cloud in order to fix something on your production system on premises, how do you bring the data back in-house, especially if you're not wanting to move the whole of the database back, but just deltas?
Mm-hmm. Yeah, so this really goes back to the use case. In data warehousing, lo and behold, you typically don't bring kind of terabytes of data back, but usually you have a ratio of very intense queries that are running for, as I said, seconds, minutes, or hours, and then typically bring back a few megabytes or a few kilobytes. And with that background, actually getting the data back, getting your answers to the queries, has actually never been an issue, because the amount of data extracted or returned compared to the computation that you executed is usually really tiny. So for data warehousing, it's actually not really an issue. This will certainly change in operational database systems, but we'll cross that bridge when we get there.
Okay, another question here is related to workload management. You had talked about Teradata having sophisticated WLM capabilities. What do you need in order to be able to do the equivalent on a cloud-native database?
Yeah, there are effectively, I believe, really two levels of that to look at. One of them is the kind of policy-based admission control. How do I get onto the system? How do I queue requests? What kind of priorities do I define there? And this is what Hyperqueue Datometry can fully take care of. We have a fairly sophisticated queuing system in there where you can define priorities, you can define even queues with exclusive access for admins, etc. And this was really driven by a lot of the experience that I had in previous jobs with troubleshooting MPP systems and occasionally not being able to do any of these things. And then the second level of this is workload management that is actually integrated into the database. For example, how the memory is being used in the database, etc. The second one is obviously outside of the reach of Hyperqueue, but we also seen that the importance of that is gradually minimized because of all the implements that you get with the cloud. Some of the cloud data players today move already even to the kind of the extreme of saying, hey, no knobs on this. You get query performance. We make sure through adaptive optimization, through machine learning, that we get you the right resources, etc. You shouldn't be burdened with having to parcel out memory or defining any of these things. And so that is something that naturally the cloud-native databases take care of. And so then we're left with, well, how do we make sure that 1,000 concurrent connections get metered onto the database in a reasonable fashion? And that is really one of the sweet spots of Hyperqueue.
Another question here is about scaling. Does Hyperqueue manage the scaling in and of itself, or do you as the administrator have to go in and manually deal with the cloud database scaling?
So right now we're not in any way taking care of or interfering with the database setup, simply because this is something that is very often a matter of not only just scaling to workload requirements, but also a matter of billing, pricing, internal policies, etc. So this isn't something that, at least not for now, we want to take on. But then there's also all the scaling of Hyperqueue. And Hyperqueue was really designed to scale both vertically and horizontally. And by vertically, I mean you just plug in a bigger box, more cores, more memory, etc. But you can also go horizontal. And for example, put this into an auto-scaling group and then have the cloud primitives around that take care of it and fire up multiple instances of this. So that gives you scalability, at least on the Hyperqueue side, that is very easy to maintain and configure, and is way beyond what we actually seen in requirements. So far, we haven't seen anybody who needed more than one single Hyperqueue instance for scaling.
Okay, we have one question here that is from an attendee that is looking for just sort of a really quick breakdown of what Hyperqueue offers that Snowflake doesn't, and what are the advantages one over the other?
That's an interesting one. So first off, keep in mind that we are not a database. We are a virtualization platform that allows your applications to talk to, in the long run, any database. And so you make your choices as to what database you want to go to, primarily based on what's the scalability, what's the various billing and pricing models, etc. And we strive to make up the difference in features from your existing data warehouse moving to that data warehouse. Snowflake is one of the multiple systems that we support, and we're closely partnering with them. And naturally, there are a number, and this is true for every database system, there are a number of features that are just so inherently unique to the existing data warehouse, and that in a lot of cases might even be outdated because they predate standards, and newer databases implement this in a completely different way. Window functions are one of these examples. And we effectively reconcile that feature gap. Obviously, I'm not going to make any recommendations here as to what is the database system you want to go to, simply because that really depends on your personal choices, on your personal requirements. But the good thing is we effectively allow you to go to any of these and not having to worry about what your applications use today and whether this would work. It just will work. That's the simple thing.
Okay, so we have a question here about the overhead. And what is the overhead of the translation layer? Has it been measured? And what do you do about SQL statements that are precompiled using the prepare statement and into cached access plans that are repeatedly invoked?
All right, getting into the details here. I like that. So in terms of the overhead, obviously we're monitoring this closely, and we have our own kind of performance experiments for this. As I said before, this is usually in the range of a few to a few hundred milliseconds. And you need to view this in the context in which we operate, and that is data warehousing. So typically running almost any of your classic analytics or BI queries takes way longer. So from that perspective, we usually end up with less than 1% or less than 1.5% of the overhead. Your mileage varies depending on really the queries and the configuration of the system, no question about that. The other element is really around prepared queries, and that is something that doesn't actually kind of happen too many times in data warehousing. It's really more kind of a transactional or transaction processing workload that takes care or makes use of these. Naturally, as the downstream system, as we call them, the cloud database, offers any of these implements, we'll happily use them and implement it in the same way. But if there's something missing, like preparing of statements and calling them in a parameterized way, then the query will just be submitted separately. And that usually, as I said before, that doesn't really matter so much as long as you have the flexibility and the elasticity of the cloud database. And instead of having to worry about whether a query is prepared or tuned in a particular way, you just move the slider on your console and add a couple of servers. And for $2 more for the year, you get rid of that problem altogether. So it hasn't been a problem at all in the data warehousing space.
Okay, following on from that, there's a related question. How does HyperQ break down the procedures? Is there a machine learning model to learn based on previous queries? So
right now, when it comes to unrolling functions, it's a very deterministic process. There's very little leeway in terms of what you do. And we execute these, we break them down into individual statements, and the granularity at which we do that, and the implements that we use to execute that obviously depends on the cloud database. We try to make the best use possible and optimize for whatever the new database offers us in terms of implements to work with. But it's a fairly mechanical process of doing so. But one very interesting element that is in this question, and that is actually a really important one, is naturally where we sit, being the application on our left and the database on the right of us, we're in a unique position to actually understand workloads, to build much more elaborate models than just translation, and over time learn a lot about these workloads. And we started in the last quarter with a couple of extra insights that we gained from this. For example, whether your database has specific hotspots in there, or whether you might want to replicate the database to have multiple instances to talk to. And without going into the details here, but this is information that you can learn only if you are in that kind of unique and privileged position we are in, that we see all queries go in, all data come out, and actually offer additional insights into how you might want to tune or orchestrate or deploy your database. That is an area where I think we've just kind of scraped the surface, but that offers really, in my mind, a huge potential going forward, and that is certainly something that we at Datometry want to pursue.
Okay, now there are two forces in the database market that have been around for some time. One is a drive towards standardization. Another is a drive towards feature richness. These have been around for some time, and they will conceivably continue. How do you see this affecting the work that Datometry is doing here? Do you believe it will make it easier or harder over time?
So we have naturally initially chosen systems that are in some way kind of, I don't want to say too similar, but where the expressiveness of the systems is at least within kind of an order of magnitude. For example, going from an enterprise data warehouse to a NoSQL database is a really tough move, and to the best of my knowledge, apart from any corner cases, nobody has really succeeded to make that work generally. But right now we're looking at SQL databases on both sides, and the standardization certainly helps a little bit with it. But when it comes down to SQL programmers use idioms that they're familiar with. And very often they don't know actually whether these are proprietary or standard idioms. And whatever gets the job done will be used. And so naturally we've seen this huge proliferation of kind of syntax quirks, sometimes abbreviations, special keywords, what have you. And they are typically pervasive. They are throughout entire workloads. And even though the rough structure of the query is very clear, and it's very clear what the standard way of writing these would be, it's also very clear that the slightly modified or system-specific way of writing these just makes things easier on SQL developers to kind of wrap their head around and be productive. And with that background, I believe we'll just continue to see a proliferation of these. And standardization or not, it will not be that relevant for existing applications. So that's just going to be a trend that continues. On the other hand, what I just said before, that's really kind of the trajectory of Datometry. This is really our first act of kind of acting as a hypervisor between applications and databases. But then going forward, there is so much more value that we can bring to the table, be it around the whole workload management, about security, about auditing, about compliance, all of these things, because we have our hands on the connection, because we see the queries go in and out. And this is really where I think long-term we'll be providing a lot more value than what you've seen so far. Okay.
Let me sort of move more towards the systems administrator side of things here, with a bit of a nasty question that has been rattling around for a while. Are cloud-native databases really ready for this? Are they really ready to take on these enterprise workloads and these potentially very complex queries? Things like Oracle's database, like Microsoft SQL, they've evolved 4 decades longer than the cloud-native databases.
All right, yeah, this is a good one. So first off, if you look at where the cloud-native databases came from, they have, at least intellectually, kind of always had a pedigree to these systems, primarily because they were either emerging from the existing systems or, in other cases, the founders of the companies have had a decade or more experience in this space. So there's a lot of kind of informed decisions that go into these. But very much to your point, it's really just the last 12 months that we actually see uptake that is really confidence-inspiring. Cloud databases like SQL Server in Azure or on RDS have been around for quite a while. And there's certainly a solid uptake on these, but it's really a tipping point that I believe we've reached now, where suddenly entire enterprises are moving, and therefore it's no longer a matter of just the database folks to say we want to go there or stay here. It's in a much broader context, and that has accelerated this dramatically. Now, at the same time, cloud-native databases are certainly still early days, no question about this, but they've been picking up in terms of feature development, in terms of scalability and performance radically, because all of the cloud service providers and database vendors have understood this is a unique opportunity where the entire database market is just kind of in upheaval over the next 5-10 years, maybe even shorter than that. And that's a unique opportunity for them to kind of get in here and secure their spot. And if you just look at the amounts of money that the various vendors, both cloud service providers as well as database vendors, have been spending in this space, it's clear that they are banking on this. And the results are also very obvious. Their systems have become fundamentally better just really in a matter of months. It's great to watch this. And compared to on-premise database systems, the beauty about the cloud-native database systems is that you're not going through these endless release cycles anymore. You get the newest, the greatest within weeks. You get these constant refreshes of hardware. You get constant refreshes of software. And that has just fundamentally kind of redefined what the database market is. So a lot of the classic cruft and risk that we've just come so acquainted with, all of this seems to be kind of going to the wayside, and people are really adopting these and moving forward.
Okay, well, we've got about 3 minutes left, so I'm going to close this off with one last question here, and it's a really good one. What about future-proofing? What happens if the underlying languages change, or the cloud provider decides that they're going to, make some significant changes when, as you said, they're constantly rolling out the new versions, and you don't necessarily have any level of control over that in the same way that we do with the on-premises databases. How is Datometry going to handle that sort of change and or provide any future-proofing to developers there?
Yeah, this is a very good one, a very important one. So naturally, we were partnering with all the major players, so we actually do get a kind of a peek at what they're going to roll out or how they're going to change the product. At the same time, databases is an area where vendors have been very, very diligent about preserving backward compatibility. I'm not actually so much worried about the backward compatibility, but for example, an individual vendor might offer different database systems within the same ecosystem, and your workload should probably, let's say, not reside on the data warehouse, but should probably move over to the operational database system. And as part of what we call future-proofing, we just let you move this direction very simply and without any major pains. And so you get actually to test drive some of these things. Another element here in the future-proofing is, as these systems are on a rapid development, the way you would rewrite a query today to meet, let's say, version 1 of that cloud database might be very different than version 2. And in version 2, there might be a much more elegant and much more efficient and effective way of rewriting things. And so if you do a manual migration today to version 1, you're basically back to square one, because as version 2 comes out, well, you would have to go back and now re-platform to version 2. And again, we just remove that burden from you. You just plug in there, you run your existing applications as is, and you just move forward and rev the database, rev the system that you want to go to. That makes it very easy.
Excellent. Well, thank you very much, Mike. I know that I've learned a lot during this. I'd like to say thank you very much to all of the attendees and to my colleagues at Virtualization and Cloud Review for hosting this. I hope everybody has an excellent day, and I hope to see you again at another Fireside Chat.
Thank you, Trevor. You guys did a great job today, and I'm sure the audience really enjoyed it. And we really appreciate you guys taking time out of your busy schedule to be with us. And is there anything either of you would like to add before I close out the event?
Well, thanks for hosting us. I think this was a really great conversation. Thanks, Trevor, for some of these nasty questions. And I hope we could really shed kind of light at what we think is really a redefinition of the entire database market. There's obviously more information that is out there on our website, as well as a couple of outlets already. And at any point in time, we'd love to interact with you to answer additional questions.
Very good. Thank you so much. And I'd also like to thank the audience for attending today. The webcast was sponsored by Datometry and presented by Virtualization and Cloud Review. Thanks again, everybody, and enjoy the rest of your day. Bye-bye.